For the function f of x equals 2 by x minus 3 squared minus 10, we are asked to do several things. To determine whether the parabola opens upward or downward, find the axis of symmetry, the vertex, the y-intercept, and a point symmetric to the y-intercept across the axis of symmetry, find the x-intercepts, and use that information to graph the parabola. Alright, so first, let's determine whether the parabola opens upward or downward. Now, we're given a different form of the function than we've seen in previous videos. Here the function form is f of x equals a by x minus h squared plus k. When we see an equation of this form, it's called sometimes the vertex form. But what's important, first of all, is that the a value is the same as the a value in the other form that we studied. And the parabola will still open up if a is positive or open down if a is negative. So here we have a equals 2, and so therefore a is positive, the parabola will open upward. Now we're asked to find the axis of symmetry. Well, in this form, if we see a function of this form, what we can immediately tell is that the vertex is the ordered pair h, k. The h, whatever makes the inside quantity 0 is the value for h, and k is just this value, whatever is being added or subtracted. So I'm going to answer part C first. Find the vertex. The vertex is 3, negative 10. And so then the axis of symmetry, remember, the vertex is on the axis of symmetry. It's on the vertical line that the vertex is on. Okay, so the axis of symmetry is then x equals 3. Find the y-intercept. Well, to find a y-intercept for any graph, you find the function's value at 0. So the function's value at 0 is 2 by 0 minus 3 squared minus 10. So that's 2 by negative 3 squared minus 10. So that's 2 by 9 minus 10. So then that's 18 minus 10. And so f of 0 is 8. So then the y-intercept is 0, 8. Find the point symmetric to the y-intercept. Well, I know that the axis of symmetry is x equals 3, and I know the y-intercept is 0, 8. Let's look at this graphically. Using a scale of 1s, 1, 2, 3, 4, 5, 6, 7, 8. I know that the y-intercept is at 0, 8, and I know the axis of symmetry is at x equals 3. So here's the axis of symmetry at x equals 3. And so the axis of symmetry, what that tells me is I should have a mirror image of the y-intercept on the other side. And so since this distance right here between the y-intercept and the axis of symmetry is 3 units, then I should be able to go 3 units on the other side and get another point. And so then the point symmetric to the y-intercept would be then 6, 8. This point right here is 6, 8. Now we're asked to find the x-intercepts. So to find the x-intercepts, we will set the function equal to 0. We will set the 2 by x minus 3 square minus 10, set that equal to 0, and solve for x. I will add 10 to both sides. 2 times x minus 3 squared equals 10. I'll divide both sides by 2. So x minus 3 squared is equal to 5. I will apply the square root property. So x minus 3 is the positive or negative square root of 5. And I will add 3 to both sides. X is equal to 3 plus or minus the square root of 5. Now, if you have a calculator handy, you can approximate these values. 3 minus the square root of 5 is approximately 0.76. And 3 plus the square root of 5 is 5.24. So then my X-intercepts would be at 0.76, 0 and 5.24, 0. So now let's use that to graph, and everything else we've seen, to graph the parabola. My X-intercepts, adding those to my graph, we're at 0.76, 0, so about here. There's about 0.76. Oops, sorry about that. 0.76, 0, and 5.24, 0. That's about here. And my vertex was at 3, -10, so that's here. And so, using all that information, I can draw a rough sketch of the parabola. So let's see if I can get this reasonably done. We need that U shape, and my vertex is the lowest point on the curve. And so get something like that. And there's the graph of the parabola using all of that information.